Okay guys, like in the last video I said, I'm not going to be there all this week. But after you watch this video and you guys are working on the homework, if you have any questions, please reach out to me through email. I'm going to be at my computer all day. So I'm still here to help even though I'm not physically there. So this video we're going to talk about literal equations. So if you can go ahead and write this into your study journal. After today, the goal is that you can solve a literal equation or an equation with variables other than x and y. So a literal equation is an equation which consists primarily of letters. Formulas are an example of literal equations. So we've seen quite a few formulas for literal equations. So I mean, slope-intercept form could be considered a literal equation. You've seen this one before, a squared plus b squared equals c squared. Okay. We might not know what a, b, and c are, but they are variables. One of the first ones in our book, literal equation that we use is the conversion from Celsius or from Fahrenheit to Celsius. We're talking about degrees, and that is degrees Celsius is 5/9 times the degrees in Fahrenheit minus 32. Okay, so it's just equations that are built up of primarily letters, and we're also going to be using what we've learned or what we've been practicing in solving multi-step equations and rearranging these formulas. So for example, if I asked you to solve for f, so if you were doing this equation and you were to solve for f, you would want to get f by itself. So we're going to get to that in a minute, and we're going to practice some others. This is in your book. This is 3.4. So I want you to turn to that in your blue book, section 3.4. So what it's asking is us to convert between Fahrenheit and Celsius using the literal equation that it gives us. So if I know what the degree is in Fahrenheit, I want to solve it for Celsius. So if I want to figure out what 98.6 degrees is Fahrenheit, I'm going to write up my equation. Now I've got my capital F. I know what that is. It's 98.6. And I'm subtracting 32. So you're probably going to want a calculator for this, because I can't do it in my head. So if I pull out my calculator, for that one I get, and tell me if you get the same thing, 37 degrees Celsius. Oops, supposed to be a C. Okay, let's try this one. If I want to figure out what negative 126 degrees Fahrenheit is in Celsius, I wrote that wrong. Hang on. So if I negative 126, I'm subtracting 32. I'll put that in my calculator. I get negative 87.7 degrees Celsius. Okay, so that's just us using a literal equation to figure out what the conversion is between Fahrenheit and Celsius. Okay, so now if we look down here below, we did a little bit of this last week. We want to convert each equation from standard form to slope-intercept form. So remember, slope-intercept form is written like this: y is equal to mx plus b. So what I want to do is I want to get y by itself. So what I'm doing is I'm performing different operations and using algebra to change or manipulate this equation. So I want to get y by itself. So if I got 4x plus 6y is equal to 48, I want to get that y all by itself. So the first thing I'm going to do, if I got 4x being added to the left, I want to get that over to the right. The opposite of addition is subtraction. So I'm going to subtract 4x from both sides. When I do that, those cancel out. So I'm left with 6y is equal to 48 minus 4x. And then I want to get the y by itself. So to get the y by itself, the 6 is being multiplied by y. The opposite of multiplication is division. So I'm going to divide both sides by 6. And here's something I got to remember. I have to divide everything by 6. So when I do that, that cancels out. So I'm left with y is equal to 48 divided by 6 is 8. And I'm subtracting 4 divided by 6, x. And if you guys are noticing, the 4 and the 6 are both divisible by 2, so I can reduce that. So I'm running out of room here. So I'm going to be left with y is equal to 8 minus 2 all over 3x. And then that's not quite in a slope-intercept form yet, so we'll just have to swap those. So I end up with, I'll write it up here in, let's see, green. So I end up with y is equal to negative 2/3 x plus 8. Okay, so last week some of the homework was doing exactly this. So we're working with literal equations, so slope-intercept form or standard form, those are both literal equations. We're just manipulating them, or we're changing them around, okay, using algebra. And using some of the multi-step equation things that we've been practicing. So I want you guys to go ahead and try that one right there. So if we can go ahead, if we can pause the video, go ahead and try that one right there and get y by itself. So to get y by itself, first thing I'm going to do, subtract 3x from both sides. Man, sorry, I need my stylus. I can only use my finger. So that goes to 0. So I've got negative 5y is equal to 25 minus 3x. Okay. The next thing I'm going to do is I want to get that y all by itself. So I'm going to divide both sides by negative 5. When I do that, I got to divide everything by negative 5. So those cancel out. So I'm left with y is equal to 25 divided by negative 5 is negative 5. And minus 3/5 x. Okay. Now I'm just going to rearrange those two. So I get y is equal to negative 3 over 5x minus 5. Okay, so now I'm looking at some equations that are written in slope-intercept form, but I want to write them in standard form. Remember, standard form is ax plus by equals c. Okay, so I'm going to write them in that form. So what I'm going to do is I want to move this 5x to that side. So I'm going to do that by subtracting 5x from both sides. So if I subtract 5x from both sides, I get negative 5x plus y is equal to positive 8. Okay, so that is in standard form. So that one was pretty easy. Now if I have one like number 9 here, looks a little bit different. It's got fractions in it. When I do this one, okay, I want to move this 2/3 x over to the other side. And then when I do that, I want to try and get rid of that fraction. So we're going to see how we do that. So first thing I'm going to do is I'm going to subtract 2/3 x from both sides. Holy cow. Okay. So when I do that, those cancel out, give me 0. So I've got y minus 2/3 x. And that's equal to -6. Okay, so I'm going to get rid of this 3 on the bottom here, in this fraction. In order to do that, I want to multiply both sides by 3. When I do that, this 3 and this 3 are going to cancel out. Remember, I got to use the distributive property. I got to multiply everything by 3. So when I do that, I got 3 times y is 3y. So the minus. And then remember, this 3 and this 3 are going to cancel out. So I'm left with 2x. And that's equal to -6 times 3, which is -18. Okay. All right. Let's try number 10 here. So first thing I want to do is I've got 1/2 y is equal to -1/4 x plus 5. So I want to move that -1/4 x to the left side of the equation. So I'm going to do that by adding 1/4 x to both sides. Okay, so when that happens, those cancel out. So I'm going to write it over here. So I've got 1/4 x plus 1/2 y, and that's equal to 5. Okay, now I want to get rid of these fractions. So in order to get rid of these fractions, I want to multiply both sides by something so that my 4 and my 2 cancel out or reduce down to a whole number. So if I do that, this one's actually a little unique because 2 is a factor of 4. So if I were to multiply both sides by 2, let's see what happens. So if I multiply both sides by 2, let's see what happens. Well, I've got the 2 times the 1/4, which gives me 2/4 x, and I got the 2 times 1/2 y, which gives me 2 over 2y, which is just 1, or just y, and then that's equal to 2 times 5, which is 10. Now if you'll notice, the 2 all over 4 can also reduce down to 1/2. I got 1/2 x plus y is equal to 10. Okay? And now I want to get rid of this other fraction, this 2. I want there to be a whole number in front of my x. So to do that, I'm going to multiply both sides by 2. Okay? So when I do that, so I got to distribute here. Man, it's getting messy. Sorry. So then I got 2 all over 2. Come on. X plus 2y. That's supposed to be a y. It's equal to 10 times 2, which is 20. If you notice, these reduce to 1. So I've got x plus 2y is equal to 20. Come on. Nope. Nope. It's equal to 20. It's supposed to be y. Okay. Okay, so now we're going to work with some different equations here. So we're not looking at a linear function that's in standard or in slope-intercept form. We're looking at just the area of a triangle, and this is the area of a triangle. So A equals 1/2 times base times height. So what I want to do is I want to solve for h. So I want to get that h, I want to get that h all by itself. Okay? So to get that h all by itself, I want to first probably get rid of this 1/2. So to get rid of that 1/2, I want to do it kind of what I was doing before. I'm going to multiply both sides by 2. So if I multiply both sides by 2, I get 2a is equal to 2 all over 2 b times h. Okay? And what happens to those 2 all over 2? That reduces to 1. So I'm left with 2a. It's equal to base, not a nose, base times height. Okay, and now I want to get the h by itself. H is being multiplied by b. So in order to get the h by itself, I'm going to divide both sides by b because division is the opposite of multiplication. Okay, when I do that, those cancel out, and I get 2 times the area divided by, assuming that's the base, is equal to h. So all we're doing here is manipulating and playing with formulas and equations. Okay? So we don't know what h is, we don't know what b is, we don't know what a is, and that's okay. We're just trying to figure out a way to rewrite the equation if we were to solve specifically for h. Let's try this bottom one. This one's a little bit different. Okay, I got a is equal to pi r squared. A is equal to pi r squared, and that's the formula for finding the area of a circle. So I want to get the r all by itself. So if I've got a is equal to pi r squared, and I want to get the r all by itself. And pi is being multiplied by r squared, so the first thing I'm going to do, the opposite of multiplication is division. I'm going to divide both sides by pi. Okay? Now I know what, I have a pi button on my calculator. I know what pi is, but we're going to leave it as pi because it'll be a lot cleaner. So I know pi divided by pi is 1. So I've got area divided by pi, holy cow, divided by pi is equal to r squared. Okay, now we probably haven't talked about this a lot this year, but if I wanted to get r by itself, so if I have something being squared, how do I undo it being squared? And that is to take the square root. So like if I have 2 squared, that's equal to 4. So if I want to undo the 2 being squared, I can take the square root of 4, and that would give me 2. Okay? So to undo this squared here, this r squared, I'm going to take the square root of both sides. So if I take the square root of both sides, on the left I'm left with a all over pi is equal to just r. And if we need to, when I get back, I can show how this works using the rules of exponents. Actually, I lied. I'm going to do that right now. So if I have, and actually I'll do it when we get back. Okay. Alright, so that's how I would get r by itself. Okay, so number 13. I want to solve for a. So I'm going to get a all by itself. And if you notice, a is inside the parentheses. So I could do this a couple ways. And this is how I'm going to do it. I'm going to get the a all by itself. So if I notice that 3 is on the outside of the parentheses, and part of our quiz last week was like this. So if I have a number like that on the outside of the parentheses, I have to distribute. So I have to multiply that 3 by everything on the inside of the parentheses. So when I do that, I get 3 times A plus 3 times B, and that is equal to, holy cow, 21. Okay, now I want to get the A by itself. So to get the A by itself, first thing I have to do is I have to move this 3B to the other side of the equation. So to do that, I'm going to subtract, holy cow, 3B from both sides. Okay, and those cancel out. So I'm left with 3A on the left, and that's equal to 21 minus 3B. Okay, now I want to get the A all by itself. So to do that, 3 is being multiplied by A. The opposite of multiplication is division. What divided by 3 is equal to 1? 3. So we're going to divide both sides by 3. I got to remember here, whatever I do to one side, I have to do to the other. And I have to do to everything on each side. So if I divide this by 3, and those cancel out, I have to make sure I divide the 21 by 3 and also the negative 3b by 3, okay? So when I do that, over here I'm left with A, and then 21 divided by 3 is 7, and then negative 3b divided by 3 is just minus b. Okay? Another way I could have done that one is like this. If I notice right here, 3 is being multiplied by everything on the inside. Okay? So before I distribute, what I could do is I could divide everything on the left by 3. Because 3 is being multiplied by A and B. The opposite of multiplication is division. So I can divide everything by 3. If I do that, these 3's cancel out, and I'm left with A plus B on the left. On the right, I have 7. Because 21 divided by 3 is 7. And I want to get A by itself. So the next thing I'm going to do, I want to move that B to the right side. So I'm going to subtract B from both sides. If I do that, those cancel out, give me 0. So I've got A, and that's equal to 7 minus B. So I get the exact same answer. Okay, so literal equations. They're not hard. You're just going to see more variables than you're used to, okay? And on the homework, you're going to be asked to solve for a certain variable, and you're going to have to manipulate the equation so that that variable is by itself. So once again, if you guys have any questions, please email me. I'm here to help. Don't be afraid or shy to email me. Please do it. Make sure you're washing your hands and being safe.